my goal is now to talk about maybe the most important data structure in Python. It's called a list. Now, lists are useful to, of course, aggregate a lot of data of the same or different types and to iterate through them. So let's see some examples. Let's assign to the variable named data the object that consists of a list. And this list is a list of different objects themselves. For instance, the string Alfred, the integer 17, the string Charlie, and the string Daniel. And if I ask to print data, I'll get the string here, the list here, with a string, an integer, a string, and a string. Okay, so what can you do with strings? Well, you can access parts. And a nice thing is in Python is that you can access from the left or from the right. And remember, always start indexing at 0. So data 0 would be really the first entry, so Alfred. Data 1 would be the second entry, 17. Data -1 now starts indexing from the right. So, and there is this weird thing that there is a ghost component here. So this is -0 if you want. And then -1 is Daniel. So that's why Daniel is printed. And similarly, data -4, well, you start at -0, -1, -2, -3, -4. So Alfred is printed. Now, what would happen if you were accessing something that does not exist, like data 7? Well, this would give you an index error. And it would say the list index is out of range. So it's actually pretty explicit. I could also access from the right and go too far. And this would also give me a list index out of range. Okay, so given a list, I can test membership. So for instance, I can see if Zoe is in data or if Alfred is in data. And the answer is false and true. Another operation I can do with lists is just like with strings, I can do slicing. So here are a few examples that I'll explain now. So here I'm slicing between the 0th index and the second index. And this gives me a list of length 2, which is Alfred 17. Here I'm slicing from the -4th to the -2nd. So I'm slicing left to right still, but I've decided to put the index on the left, so the starting index, by counting from the right. And I've decided to put the index at the end, counting also from the right. Okay? Now, if you get mixed up, you will ask sometimes to lists that are actually empty, because here you're saying that the left endpoint should be further to the right than the right endpoint. So this is clearly not possible, so it will return something empty. And if you want just one character or one entry in the list, then this is not the way to do it because of the closed open thing. So here this would give the empty, just an empty list. But the way to access one specific entry using slicing is this one. Of course, you don't really need the colon 4. You could just take data 3 and this would give you Daniel. Now with slicing, you can leave one entry empty, and this is what's done here. So that means all the way to the end or the beginning, depending on where you are, which entry you're leaving empty. So here I would have Charlie, Daniel, because I'm going from the second entry, so the second index, all the way to the end. And if you count back here, you have the 0th, 1st, 2nd. So this is Charlie. And goes all the way to the end. So you have Charlie, Daniel. And similarly here, this means from the beginning all the way to the object of index 3. If you leave both empty, you are asking for a copy of the whole list. And finally, you can do this thing where you can add extra yet another column with another value. And this says this tells you how much to skip from when jumping from one to the next. Okay, so if I have data from the 0th one to the 3rd jumping by 2, I'll get Alfred Charlie, because I go from 0, 1, 2, 3. So I basically take everything from Alfred to Charlie, but I decide to do skips of 2. So I've skipped the 17. And the nice thing is you can also use a negative final index, and this means swap it around, go the other way around. Okay, so I could do this, and this would, oops, well, okay, so this does not work, sorry. But I can also use -1, and this just means going backwards. Okay, so unlike with, so you might think, okay, this is just like strings. I can do the same things and everything's fine. Well, yes, but you can do more. So, well, strings can only contain characters, first of all. With lists, you can contain anything you want. You can contain strings themselves, you can contain other lists, you can contain other types. So that's all fine. But you can also modify the content. Okay, so lists are mutable, unlike strings. So you can take the second entry and replace that with Charles. And you can add 1 to the first entry. So this has replaced, I think it was Charlie by Charles, which is much more dignified. And the 17 is increased by 1 to 18. And you can also assign using the negative indexing. So the last entry here is now called Greg. And this messes up all alphabetical order. Okay, so because the alphabetical order is messed up, we now want to introduce something else. So we want to introduce some new names between Charles and Greg to fill that gap. And this is done with slice assignment. So this is saying replace what's going on between the -1st entry and the -2nd entry with this whole thing. Okay, so it's saying, if you look back at data, replace everything that's happening in there by what I've put here. Okay, so it's not just inserting a substring, you could do that too, but it's not what it's doing here. It's selecting all this blue part and replacing it with the string on the right. And so now I have Alfred, 18, Carlos, David, Enrico, Fred, and Greg. Okay, so this is good, but it's still limited in, if you want, in the alphabetical order. So I want to add stuff at the end. So I can do it with extend. So extend just goes at the end very quickly. It's actually much quicker than other possibilities here that you could do. And adds at the end another string, which is the string that is given as input. So with Janet. So now I have a whole big long list that is the original data plus with Janet. Okay. Another thing you can do with lists is access the last element and actually remove it. So here is what pop does. So pop will access the last entry, which is clearly Janet here, and return it. So last will be assigned the last entry. But on top of that, data is actually modified. So if I ask to print last and data, I see that I'll print Janet, which is was the last entry indeed, but I'll see also that data has been modified. So now it's left hanging with this with at the end. Now that you have a list, what else can you do? Well, you can decide to delete specific entries, and for this you use del. So del, and then you pass in the entry you want to delete. So here I've taken the last one, but you don't have to do that necessarily. I'm just saying remove it from the list. And you can see that indeed I've removed the last entry. So we've seen extend so far. That was extending a list with another list. You can also append. So append, if you want, extends the list with just one entry. So data ended at Greg, but if I want to append Hector, I can, and now data has Hector at the end. And I can of course append also Ivan, and that's kind of needed if I want to keep the alphabetical ordering here. Okay, so now I have Ivan at the end after Hector. Okay, so something else you can do with lists is access their length. So here the list is of length 10, and you can also ask for a specific element. So where is Fred, for instance? And Fred is at the 5th entry, the 5th index. But if I ask for Frederico, Derico, this would give me a value error. Frederico is not in the list. Okay, so we saw extend before, which allowed to add a list at the end of another list. And I mentioned that this was quite quickly. This is quite quickly because it's done in place, what's called in place. The data that I had was modified in place. The old data was gone. I didn't have it anymore. I just modified it. If you want to create a new object, you can as well. And for this, use plus. So data right now is that, but I could do data plus and a koala, and this is the output I have. I have a list where I have added and a koala at the end. But so you could say this is just like an extend, but it's not, because data has not been modified here. Okay, so if you look back at extend was modifying data, and here what I have done is actually create a new object. So let's go back to this new object that's created, and let's assign it to data. So I'll actually want to modify here data. Okay, so this is because it's my running example here in the course. Now another thing I can do is reverse the list, and again this is done in place. So I have data and I'll just reverse it. You see that this prints nothing in return because it's just applied to data and nothing is supposed to be printed. But then I can ask to print it anyway, and I see that data has been reversed indeed. Okay, so another thing I can do is sort. So now that data is in reverse order, I can go back and I can ask data to be sorted. And again, there is a difference between sorting data and applying the sorted function to data. The sorted function on data will return a new object, which is here, but will not modify data. Okay, so the object here is sorted and it hasn't modified data. If I want to modify data, I should use data.sort. Okay, so if I do data.sort and now ask to print data, I see that data has indeed been modified. And it's worth looking at what the ordering is. So the ordering is, well, maybe a bit arbitrary. Yes, that's the right word. A bit arbitrary when it involves different types. So for some reason, the integers are before the strings, but within a type, it's fairly consistent. So certainly the ordering that will be used for integers is the usual ordering. But for the strings, you can see that Alfred is before and a. So clearly the ordering is not based on the length of the string, but it's actually a lexicographic ordering. So just like in the phone book, A equals A, so the 2 should be very early in the list that is sorted, but then L is ahead of N. So Alfred should be before and A. Okay, so let's see this in action. Let's define data2 to be all those. So the string 1, the string 2, the string 3, and the string 11, 20, 100, and 200. So it's misleading to think of those as integers. Those are really strings. And then I'll sort them. So I'll modify data2, and I can see now the ordering that Python has decided on those strings. So 1 will be ahead of 100, which will be ahead of 11. Indeed, at some point in the lexicographic ordering, the first 0 of 100 has to be compared with the second 1 of 11. And so this way you can see, you can understand this ordering by as lexicographic ordering. Okay, so this might be a good time to actually mention a function that is useful for lists, but useful for all complicated objects in general in Python. And it's a good source of information if you're a bit lost. And this function is dir. So dir will give a directory of all the stuff you can do on the object you have passed to it. So I've taken the object data, and I could have taken the object data2 and would have gotten exactly the same thing. And I've called directory on it, and I got a bunch of stuff. So in general, all the stuff that's with double underscore is kind of very technical, and you should not pay too much attention to it right now. But the stuff that doesn't have underscore is actually very relevant to you because it's stuff you could call on data. So append is there, which means you could do data.append, right? And then append something to your data. So that we saw earlier. You can do also count. You can do insert. You can do remove, and all the others we have seen. So if you look at count, insert, and remove, I suggest you ask for help on those, and you, yes, you try to understand yourself how to use them. Okay, so this is an exercise for you. Now, so this was for basic things you can do with lists, but it should be clear right away that you can do more things. So you can do nesting as well of lists, or it should be clear right away that all those things you can do so far imply that you can do even more stuff, for instance, nesting. So nesting means I create a list here that's just the list 1, 2, and then another list which is just the list 3, 4, and then another list which is, and then an integer 5. And then I create the list which consists of the first object, second, and third object. Okay, so nested, if I decide to print it, I see this is what Python understood. And then I can access the 0th entry of nested. So this gives me 1, 2. And then the first entry, remember for the Python ordering of nested, and that would be the 2. And indeed, this is what's printed. Okay, so you can nest lists, and in general, you can use within lists any Python object. Okay, so finally, one other important aspect is list comprehensions. So list comprehensions is an easy way to create new lists. So let's see this. If I do range 10, as we saw earlier, I have the list of integers between 0 and 9. But let's do a list comprehension now to look at all the squares. And you can see how this is similar to mathematical notation. So here I'll have the list of all x squared for x in the range 10. Okay, so if I ask to print squares, I'll have all the squares. So that's very nice. It's even nicer because you can actually do tests within the list comprehension. So I think you should be able to read this whole thing and make sense of it right away. So this is all the tuples. Okay, tuples we haven't seen yet, but it's all the pairs x, y for x in squares, for y in squares, if x plus y mod 5 equals 0. So basically, I'm asking for all the pairs of squares so that their sum is congruent to 0 mod 5. And you can see that this seems like the right list. So 16 is a square, 49 is a square, and the sum should be 75, or of course I got that wrong, 65, which is congruent to 0 mod 5. Okay, so this will give me, this is a list comprehension, and it's a list comprehension that involves 2 fors and 1 if. So I think here there's a subtlety, and the subtlety is what would happen if I swapped the x here and the y there. So I would get the same list, actually not exactly the same list, I would get the same entries in the list, but in a different order. So it's interesting to see that this for x in squares, for y in squares, means that I'll first fix the value of x, and then I'll fix the value of y. And that's why you see that going from the beginning to the end, the value of x always increases, while the value of y increases, then goes back to 0, then increases, goes back to 0, increases, and so on. Okay? So if you remembered, nested had this value, and one last thing that you can do is you can, or one last type of use of list comprehensions is to flatten, oops, oh, yes, so let me correct this. So I would like nested to be this now. Okay, so nested is a list of lists, and I would like to print to do what I was trying to do before. So print all the x's for y is in nested for x in y. So you can make the list that you're iterating over dependent on the previous one. Okay, so y here will run through the sublists that are inside of nested, and x will run through the entries in that sublist. And then I make a list out of that. So I have now 1, 2, 3, 4, 5, 6, and that's my whole list. Okay, so this is a way to flatten the list nested. Now maybe it's a teachable moment or whatever the name is, to go back and see what went wrong. So here I was trying the same thing but with nested like this. So when y was reaching the entry here, the last entry, y had the value 5. And then I was iterating for x in 5. But 5 is an int. So what it was saying here is the type error. The int5 object is not iterable. Okay, so that's what Python was trying to tell me. Okay, so now we have lists. And once we have lists, the next natural thing to do is iterating over the lists. And we've sort of seen already something like this with the for that in the list comprehension. But you don't need to use this for inside a list comprehension. You can also use for as a statement on its own and do complete complicated iterations. And that's what we'll see next in this Python grammar.